All right, go and have your homework handouts out if you would, please. And had 5 problems to complete on this handout, dealing with the Nile River and Mississippi River and Missouri River and then an airplane. So let's go ahead and take a look at those. And as we go over that, let's review over some different types of vectors that we talked about. Again, a vector class, any quantity that has both
direction and magnitude.
Direction and magnitude. Oh, yeah. And we said that if vectors have the same magnitude and direction, class? Same magnitude, same direction? Equal vectors. Equal vectors. What is a vector? Magnitude and direction. If they're the same, they're equal vectors. What if they're in the same direction? Parallel vectors. What if they're in opposite directions? Anti-parallel. What if they're along the same line, either anti-parallel or parallel, but along the same line? Collinear. And we looked at solving collinear vectors here on our handout. What about vectors that act at right angles to each other? Perpendicular vectors, and we worked on some of those as well. Now, after the exam, we'll talk about vectors that they're not collinear and they're not anything. They're just weird. Class? Skewed vectors. Good, kind of skewed vectors. In general, though, what we were looking at in the homework is, and what we'll be looking at all throughout Chapter 7, are vectors that act at the same time on the same object. How do we describe multiple vectors that act at the same time on the same object? Class? Concurrent vectors. What is it, class? Concurrent vectors. And the goal with concurrent vectors is to figure out, okay, we got all these vectors acting at once. Maybe it's 2, maybe it's 3, maybe it's 4. We'll work up problems where there's lots of vectors acting at the same time. But when it all comes down to it, there's one vector that shows the outcome. What do we call the one vector that shows the outcome of all the concurrent vectors? The resultant. The resultant. And so really what we were working on here was finding the resultant of all these different vectors. Now, in the first problem from the homework, it says Brandon swims south in the Nile River at 6 miles per hour. The Nile River flows north. It's the only river in the world that does it, to my understanding, at 4 miles per hour. What is Brandon's resultant velocity? And again, this assumes Brandon doesn't compensate for the Nile River's flow. Audrey, what do we have to do here? Just subtract, because they're going exactly opposite each other. He's going 6, it's going 4, so we subtract to get 2 miles per hour, but who wins? Brandon, so which direction wins? South. So there's my magnitude, there's my direction. How many have 2 miles per hour south for your answer? Next one says a plane's flying due east at 150 miles per hour, and the wind, and as a wind from the west. If it's coming from the west, where's it going, class? East. So the wind is coming from the west up behind the plane at 10 miles per hour. So what's the resultant velocity of the plane, Kendall?
160 miles per hour.
All right, there's the magnitude. We add because they are together, but then the direction?
East.
East. All right, how many had 160 miles per hour east? All right, questions on that? All right, Jake paddles a kayak downstream at a rate of 8 miles per hour as the river flows at a rate of 3 miles per hour. What is Jake's resultant velocity? Michael?
11 miles per hour downstream.
11 miles per hour and downstream is how we would describe the direction. Technically, you could argue, since he didn't give a north, south, east, west, you could also use positive as Jake's direction. And since the river was going with him, he was going downstream. That's another positive 3 gives positive 11. But I like that he said 11 miles per hour downstream. Here we go. Here's a little birdie. Bird flies north at 7 miles per hour into a gale force wind from the north. Now, if it's from the north, which direction is it going, class? South. At 23 miles per hour. What is the bird's resultant velocity? Audrey? So it should be miles per hour south. Good. The other way to think of this is if the bird is positive, since it's flying in the face of the bird, where the wind is negative, so we could say either negative 16 miles per hour, but since directions were given, the preference would be 16 miles per hour south. Since they gave a north, south, east, west in the problem, we would prefer to use that. If it's not given, well, then we'll go with the positive, negative. Questions on the first 4 problems. First 2 boxes, first 4 problems. We feel good about collinear vectors. Now come the calculators, I think. Yes. Lewis and Clark try to paddle a canoe across the Mississippi River west at 7.25 meters per second. That's pretty fast. But fail to account for the current which flows due south at 5.37 meters per second. Anytime you're dealing with perpendicular vectors, start with the intended action and the effect, the secondary effect, start at the head of the first vector, put the tail there, so that we get this. In fact, I'm going to rewrite this up here, so that we get this perfect right angle in our picture. Now, how do I put the resultant in the picture, though, Kendall?
A dotted line.
From
The end.
start
to finish.
to finish. So the dotted line is going to go here. There's the resultant. How do I always find the magnitude of the resultant of perpendicular vectors, class? Pythagorean theorem, right? We've got a right triangle formed by the perpendicular vectors. You're just going to use the Pythagorean theorem. So you should have squared the 7.25, squared the 5.37, added, taken the square root. What did you get for the magnitude of the resultant, Kendall?
9.02.
And that's not what you had before.
No.
All right, so you should have had 9.02 meters per second. All right, does that make sense now? All right, did you both have 9.02? And again, you should. You've been doing right triangles a long time now in pre-cal. She hasn't. It's been since geometry a couple of years ago, year and a half at least, since she's done this. So Kendall, makes sense? That's the easier part in my mind to get. The harder part is you got to figure out, this is where they wanted to go. This is where they actually ended up going, right? So they got pushed off course at some angle. I'll use the Greek letter theta to indicate the angle. They were trying to go, class, west, or west, young man, but they were pushed to the south of west. But it's not just enough to say that they went south of west. We want to know the actual angle at which the canoe would have been pushed. So to find the angle, we're going to use a trigonometric function. Kendall, do you remember which trig function we have to use? There's three big ones, sine, cosine, tangent. We're going to use the tangent. And we need to remember that the tangent of any angle theta equals opposite over adjacent. So if you remember back to your junior high days, SOHCAHTOA, TOA is the tangent opposite adjacent. Well, what is the opposite, Kendall, from this angle theta?
5.3.
The secondary vector, the 5.37, and the adjacent is the
7.25.
the primary vector, right? So always put secondary over primary, and that is the tangent of theta. But to get just theta, I have to cancel away the tangent. And Audrey and Michael, how do I cancel a tangent away? You take the arctangent, and what you do to one side, we have to do to the other. So really what I said is we use the arctangent, or the inverse tangent, second function of tangent, to find the angle. So when we plug that in, what angle do we end up getting here, Kendall?
36.5 to...
Good. Round it off to the 3 sig figs. We'll say at 36.5 degrees south of west. Did you both get the 36.5 degrees south of west?
I got south of west, but I forgot the degrees.
Forgot south of west, just forgot you had to find the angle. Just left the magnitude of the resultant. Okay, so a good reminder to us there. Questions on that? All right, let's take a look at the next one. Lewis and Clark reached the Missouri River, still trying to paddle their canoe due west at 7.25 meters per second. The Missouri River flows due east at 4.50 meters per second. So they're trying to go west, 7.25 still, and the Missouri River flows east at 4.50. Oh, well, these aren't perpendicular, class. These are collinear anti-parallel vectors, aren't they? So all I have to do is subtract Michael. Well, I don't subtract Michael, I subtract. Michael, what do I get?
2.75 meters per second.
Good, it's 2.75 meters per second, and they win out over the current of the river west. So it's slow going, but they are still going west. Did we get this one? All right, we spotted the transition from a perpendicular back to a collinear. All right, and then on the last one, an airplane's flying due east at 235 miles per hour. As it flies, it's blown upon by a strong north wind. Now question, which direction does a north wind blow? It blows south, right? Here in the south, it's always hot, except when a north wind blows and brings that cold air down, right? So it actually blows to the south 38 miles an hour. That is a very strong wind. So it's flying east at 235 miles per hour. The wind blows south at 38 miles per hour. Now, if you had it going north, your answer would be the exact same, except you would say that the plane was pushed, class, to the,
North of
well, you should have south of east, but you would have had north of east if you had the north wind actually going north. Okay? So again, start to finish, there's my resultant. Did you draw the vectors correctly? Check your sketch, or maybe you had it going this way, but you had the perpendicular, you had the right angle there. All right, so to find the magnitude of the resultant, and you should have had this even if you had the wind going the wrong way, still should have the same magnitude of the resultant, class, because we use the Pythagorean theorem. And Kendall, go and find for us, what is the magnitude? How fast does the plane really go? It was supposed to go 235, but the wind is carrying it a little bit, so it's really going
238.0525.
good, rounded to the 3 sig fig, since this was the 38.0, 238 miles per hour. The plane was trying to go east, but it got pushed to the south of east. So that's my direction generally. I want to know specifically though. It was trying to go east and it got pushed down at some angle theta. How do I find the angle theta, class? Take the arctangent of opposite over adjacent. So what is the opposite over adjacent, Kendall?
38 over 235.
And we'll take the arctangent of the opposite over adjacent. What is the angle? And it's not a very big angle. It's not pushed off very far.
9.185.
You got 9 point what?
185.
Okay, so 3 sig figs 9.19
9.
degrees. So it was flying a little faster than it intended and pushed about 10 degrees-ish, 9.19 degrees south of east, if the pilot doesn't course correct, which of course he really would, but we're assuming no course correction. All right, did we get the 238 and we forgot about direction again? Or Michael, you remember the south of east, you just got to get the angle.
No, I had north of east.
You were the north of east, you had it going north, okay? All right, does that make sense? All right, go and turn in your textbooks to page 109. Page 109 now. And do problem number 3. Start by setting up the picture. Which again, picture is just arrows, okay? We're not particularly artistic, at least, well, some of you are. But in this class, we are collectively not artistic. Audrey's very artistic. Though, if you said that up in New England, it would sound different, wouldn't it? Audrey's very autistic. Wait, she's autistic. They who talk to God and whatnot. People up in New England, they cheat. Just kidding, just the Patriots. Page 109, problem 3. Ooh, look at the end. It says indicate the direction with respect to east. That means east is primary. So they didn't give them in the order they should have. They should have given you the east vector first. That wasn't very kind of them. Does it make sense that when it says give direction with respect to east, that must mean that east was primary? Does that make sense to you? Right. Did you get the picture? Now that we talked about which one was primary. It does help to know which one's primary. You'll know, in problems I give you, you'll know which one's primary. All right, at your seats, find the magnitude and direction of the resultant. Find both the magnitude and direction of the resultant. just check your answers. Did you get the 51 units, first of all, Pythagorean theorem? Did you get 29 degrees, arctangent? And did you get south of east? All right, go down to number 6. Go down to number 6 and just do part A. There's this river flowing south at 2.8 meters per second. He's trying to paddle at 3.2 meters per second. Find his velocity is going upstream, northward. Part A. He's going upstream, northward. And for part A, what is our resultant? Kendall?
0.4 meters per second. North.
There we go, 0.4 meters per second north. We good? All right, part B. What if he turns around and decides, forget this, going upstream is too hard, I'll go downstream. So if he goes downstream at 3.2 meters per second, goes downstream at 3.2 meters per second, what is his resultant velocity? Audrey?
6.0
Good. Notice, by the way, it is 6.0 because we need to show the tenths place value since all we're doing is adding and subtracting. This is why 0.4 was correct, by the way. I should have mentioned this on the last one, because it's tenths place. It's not about number of sig figs with addition and subtraction. Did you also have 6.0 meters per second south? All right. What if he decides to go from Alabama into Georgia? He goes east at 3.2 meters per second. He said upstream and downstream is too hard. Let's go across the river. 3.2 meters per second east. And then finally, if he decides, you know what, Georgia's not so hot, I want to go back to Alabama. Well, if you can imagine somebody saying that. And so he decides to go west. 3.2 meters per second. And it looks a lot like the last answer, doesn't it? Except it's not south of east, it's south of west. But you have the same two vectors, so you're going to get the same magnitude. And since you have the same two vectors, it's going to be the same angle, right? It's just south of west instead of south of east. Questions on this? All right, go and clear your desk, except for a clean sheet of paper and a pencil and a calculator. Clean sheet of paper, pencil, calculator. Everything else away. First, let's name at the top of your paper along with today's date, which is 10/4/22. If you lived in St. Louis, Missouri, today would be Yadier Molina Day by official proclamation of the mayor of St. Louis. But you don't care about baseball or the Cardinals, so you don't care, but I care. So happy Yadier Molina Day to you. Kids all over St. Louis will celebrate by getting out of school and No, they don't even get out of school for it. Number 4, great catcher for 19 years for the St. Louis Cardinals, retiring after this season, so they're honoring him today. You don't care, I care. Happy Yadier Molina. You can put that instead of the date if you wanted to, if you know how to spell Yadier Molina. Or you just put 10/4/22. And this is quiz 9. Quiz 9. Now we're writing on it. Let's take a look at the quiz together here. Numbers 1 through 6. Ask about some different vectors. Number 6, now it should be slightly edited. The quiz copy originally says, and if you're watching on YouTube, you may have a corrected copy already, but what are vectors that do not meet any of the requirements of questions 1 through 6? It should say 1 through 5. So that is supposed to be corrected there. And then for problem solving, you be sure to draw the vectors, set up the diagram, and solve. All right, you may begin.